Hey everyone, this is Team Twins and this is the demo video of the project voice enabled reg model. So actually this is the task 2 which is given by the GOA, and without wasting any time, let's come on the demo. So first let's come on the GitHub repo, and here you can find the live demo URL which we hosted on Hugging Face. Yeah. So there are two things are there. One, either you can directly put your query. Let me put one query in English and let's see the results. So in this we are just retrieving top 10, top k, which is top 10 passages from the index dataset, and at the end using the one LLM which is Quen 2.7v, using the Hugging Face inference API to generate the final response. So in the response we are returning the rank, score and the text from the actual data set, and at the end this is the response which is generated using the LLM layer. So this is how we are doing for the text part. But in the task they also mention like we also have to use the one speech to text API either by server or 11 apps. So because this is for multilingual, so for that region we are using the server API. So let's check that also. First record some query. Let's do this in Hindi. कॉरपोरेशन क्या है? Okay, it's recorded correctly. Let's click on transcribe and ask. Yeah, it's detected. It's Hindi. Now let's wait for the GPU allocation. So this is on. We are using the 0 running on 0, which allocates the GPU if it's available. So will take a little time. Yeah. So we acquired the GPU and it retrieved the answer in Hindi only, because the query we asked was in Hindi itself, and this is the generated response from the LLM layer, which for which we are using Quen. Okay, so this is the demo part, and now let's come on the evaluation metrics. Okay, so before this, I already mentioned this. For this, we are using free version of the Hugging Face space, which is 0, and it allocates the GPU whenever it's available. So this can take time, but for the reducing the latency, we tested the same on our local, where we used the index database locally hosted and LLM quantized version of LLM, which is Quen 2.7b using Olama. Okay, then come on the repo. Yeah, so this is the repo. Let's see the evaluation metrics. Yeah, so currently so there are 14. Yeah, so the data set which we are using is this MSMARCO11, and there are 14 languages are there, but currently we did the indexing for 3 languages only: English, Hindi and Tamil. So right now we have these index data set only, and we can see this in the QD index data base. So go to the manage collection. We have 3 collection right now only, and we indexed only 50k passages for each languages: English, Hindi and Tamil. And again we are using the QD cloud, so because of that latency is a little high, but we tested the same using locally hosted Docker image, and the latency with that was around 10 times reduced. So this is the part where which we are using for indexing our dataset. And the next thing is the embedding. So for embedding we are using this lightweight model BGM3 from BAAI, and this supports a multilingual different languages, and because of that reason we chose this. uh, Come again on the repo and let's see the evaluation metrics. So for the architecture retrieval guardrails, you can see this documents. Yeah, and this is all the details which we gave. And the last thing is evaluation. So for evaluation we use the validation dataset which is provided by this AI for Bharat MSMAR dataset itself, and we are using 500 per languages, and we did the evaluation on the 248 per languages. So and this is the result, this is the ranking result, and we can see this recall 1, recall 5 and recall 10. And because the recall 10 results are good, we are retrieving 10 passages and passing that to LLM to generate the final answer. And this is the latency, and for latency we use the 10 query for each language. Yeah, so the big part which is taken by latency is LLM and qdrent. And again, because we are using qdrent cloud, this is taking a lot time. And LLM we are using self-hosted quantage. Either we can use a small language model to reduce that, or some thing other we can try, but this can be achieved. Yeah, latency can be reduced. Other things are guardrails which is again mentioned in the itself project doc. So again, we are using the guardrails to check if the query which is provided by the user is in correct language or not. It's not empty, and different things are there which can be checked in the guardrails app itself. And if you wanted to try this in your local, you can clone this repo and do the local step by the given steps. And if you face any query, you can connect over email or okay. So this is all about the project, and yeah, thank you.